Okay, students, we're about to walk into the next chapter, chapter 5, which is designated as the numbering system. And what I want you to take away from that particular chapter is one, the knowledge of it. Just understand why we do what we do. Try your best to avoid falling in that pitfall thinking that you have to know every bit of this piece by piece. No. That's just a form of calculation that we use to get to the binary system. What we actually use is subnetting to allocate each node. And when we say node, we're talking about PC, router, switch, all the many different devices we use to do networking. But I need you to focus on these numbers right up here at the top. And I said right up here at the top. Of course it's at the top. But anyway, I need you to focus on these numbers here. The 1, 2, 4, 8, 16, 32, 64, 128. I'm going to explain that more in depth in a chapter that's coming up, because this will help you understand subnetting really easy. So if you take a look at this 128, it has a 1. We consider that 1 as being turned on like a light switch, 1 up, 0 down. So that is turned on, and that's 128. Then if you go to the 32, that's turned on, and then you go to the 8, and that's turned. That will give you the number 168, which is written in binary like this. Okay, so remember that, please, because that is super important in understanding subnet. This chart right up here at the top, make sure you know that. Now let's go into the numbering system, but remember, this is just educational information. Please do not get stuck on it and think you have to know it all. This is Professor Sistrom. Let's move forward. Good morning, good afternoon, good evening. This is Professor Sistrom, and I'm reaching out to the student body. I want to talk to you about the numbering systems. Now, if you're in any of my Cisco classes, which I'm shooting this out to the Cisco students, but if you are in any of my Cisco classes, you know that we have what we call the numbering systems. This is where we begin to talk about the zeros and ones, the binary system that allows us to transfer data from one location to the next location. Let's sit back and just take a look at this particular system. As you can see, the focus of this system is just basically learning how to understand binary number systems and understanding hexadecimal number systems. See, when it comes to the binary number system, we calculate numbers between decimals, binary, and hexadecimals. One of the things that I like to stress to students, because a lot of students stress out on this particular lesson, is this. This is just knowledge to learn. It's not something that is applied. Now, a lot of professors may differ with me on that. We should make sure they can apply it. But in reality, when you're in the tech industry, you will rarely come across this unless you're in the highest level of the tech industry. And we tend to call those people architects or engineers. They tend to have to worry about these issues. One of the things that I always want to give you is practical application. What will you really do in this industry? So please don't get stuck on this. Learn it, but it's not something you want to have a conversation about over dinner. Okay? So the binary number system calculate numbers between decimals and binary system. Hexadecimal number system calculate numbers between decimals and hexadecimal systems. And it's just basically going to show you how to do basic math in a simplex way. So I'm not going to focus on really teaching you the math point of it, because we got enough examples within the chapter where you can learn it. I am really just going to focus on the highlighted portions of it, because the real thing I want to teach you is just how to do subnetting, and that's a part of this. So as you can see here, binary number system consists of the ones and zeros. Remember, I told you this earlier in class, that our communication, when it hits the pipe, which I'm talking about the media, it turns into ones and zeros to be sent out. The decimal number system consists of 0 through 9, and that's just the basic 10 base system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some people say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 truly is a number, okay? This allows the host computers, the servers, and the network equipment to be able to communicate with each other. That's the basic form right there. It allows all these different nodes. Now you're gonna hear this word nodes, and nodes simply represent computers, cell phones, servers, any equipment that is in charge of. That's what a node is, okay? Each address is made up of a string of 32 bits divided into 4 sections, which we call octets. So just know, as you see these binary numbers, we're going to talk about the 32 bits. You heard me say 192.168.10.10. Each one of these is an octet. Consistently hear me say 192.168.10.10. That is the dotted decimal system. And each one of them is an octet. Okay. So as you can see, I'm walking right through these particular slides because I want to keep it as simple as possible. So as you can see right here, it's the position of the number 3, 2, 1, 0 in the 10 base decimal system. And you can see the calculation right here, how they break it down. I don't want to spend a lot of time on this. I want you to just basically read the chapter and get the knowledge, but we're not applying this actually in the real world situations. We just giving you knowledge on how we do these calculations and come up with these. And that's just one octet. 192 would be considered one octet. Now it's another portion of this which we call subnetting, and then you're gonna be able to see it. So this number here, this positioning value, remember this: 1, 2, 4, 8, 16, 32, 64, 128. You start out with 1, then you go to 2, you double 4, double 8, double 16, etc., etc., etc. This will play a part in subnetting. So remember that. The binary positioning value table is useful in converting a dotted decimal IPv4 address. So it shows you how to do it from decimal to binary conversion. Okay, move right along. And then you got it right here on how they actually break down the calculations. So you saw binary to decimal, now you got decimal to binary. Play around with it, use it, but I want you to have a takeaway on this here, okay? And now we have 192.168.16.10, and this shows you what the binary representation is, what the decimal representation is. So this is what actually allows you to go through a router. So every router has its own IP address. Okay, now we're going to talk a little bit about the hexadecimal system. Like I said, I want you to read through that first piece. It is nothing that is really a takeaway other than that positioning value that I showed you. Now you can learn how to simply break down the binary to decimal conversion or the decimal to binary conversion, go right ahead, learn it. But in a practical world, we don't actually do it. Hexadecimal number system. And for those of you who are actually working on the field, if you actually did this type of conversion, let me know. I'm interested in hearing from you. Okay, so in the hexadecimal world, the reason this has become extremely important now is because we have IPv6, and you have to understand the conversion, how you convert IPv6. You learning this dotted decimal system, this binary system, this hexadecimal system, to get an understanding of what's happening behind the scenes. So like I said, to understand IPv6 addressing, you must be able to convert hexadecimal to decimal and vice versa. So when they put that must there, they just basically saying you need to understand this. Hexadecimal is a base 16 numbering system. That means you go from 0 to 9. Remember, 0, like I said earlier, is a number. And then you go from A to F. That gives you the 16 base numbering system. It is easier to express a value as a single hexadecimal number. And as you can see right here, here's the decimal, here's the binary, and here's the hexadecimal here. I'm not going to stay too long on here. You pretty much understand it. But one thing that's important here is the MAC address. I told you this last week. The MAC address is the MAC address that's burnt into the card that's within all networking devices. Hexadecimal is used to represent IPv6 addresses and MAC addresses. So just remember that. A couple of things here. This is how hexadecimal is represented. We use the XXXX. Then you can break them down to the binary and you can go forth there. So you pretty much get an idea of this. Like I said, you're going to read this, you're going to understand it. We have key videos placed in this chapter to give you a thorough understanding on how we do it. Just make sure you look at the videos. I'm sure you did. Each 4 hexadecimal characters group is referred to as a hex text. Just know that's what we call it. In the industry, I'm giving you real world experience. We just say hexadecimal. Okay, we don't go hexdex. No, we don't do that. Moving on. This is book stuff. Real world stuff is not like that. Okay, moving on. So decimal to hexadecimal conversions. Follow the steps listed to convert decimal numbers to hexadecimal values. Convert the decimal number to 8-bit binary strings. And as you can see it right here, you just took one, for example, 168, converted it to a hex using a 3-step approach. And then hexadecimal to hexadecimal to decimal conversions. Like I said, you're going to read through it. We got videos in there about it. If you have any questions, you can ask me.